Alright, hello Year 12s. We're now going to do some pH calculations. Okay, so hopefully you've already gone through and read up about pH calculations and you know a couple of things before we start. You need to know what the pH equation is. That was from Year 11. You need to know the Kw equation, which you would hopefully have learned already in Year 12. You need to be able to do your algebras, and you need to have an idea about limiting reagents and excess reagent calculations, okay, which is things that we've done before and we've continued to do, and we're just going to apply it in a different situation. Okay, so these pH calculations, all right, a couple of things to remember. It's very often that students will use the number of moles to solve for the pH, but you've really got to remember that you need to use the concentration of H plus to solve for pH. Okay, there's way too many times where people have used the moles to solve for pH instead of the concentration. So just please remember that. Okay, you've got to remember how to rearrange to solve for the concentration of H plus from a pH, and we'll be going through some of those later on, but you've got to be able to rearrange that equation, and that doesn't use algebra, that uses other stuff. All right. In Year 12, we're going to use Kw to solve for the pH of basic solutions, and so hopefully you've seen that a little bit, but we're going to go through some examples of some questions that will apply that. And you've got to know how to work out the pH of mixtures of acids and bases, okay? And so you've got to remember stuff about acids and bases, as well as all your limiting reagent and excess reagent calculations. So we're just going to go through and work out some, or answer some questions, which will test us on our ability to go through and remember how to do all these pH calculations. So let's go through the first one. Determine the pH of a 100 ml solution of 0.4 moles per liter hydrogen chloride. So the first thing you need to see about this is that this is a bit of a trick question. Okay, the trick question part of this is the fact that they're giving you that it's 100 mils of solution. Okay, because then you'll be thinking, okay, I've got a volume, I've got a concentration, I need to work out the number of moles, and then I'll work out the pH. But you don't need to, because you've got to remember, you're not using moles to solve for pH, you're only using concentration. So, how would we work out this one? Okay, so you need to work out the pH of 100 ml solution of 0.04 mole per liter HCl. Was it 0.04? I think it was. Yep, 0.04 mole per liter. All right, so what is the pH equation? pH is equal to negative log concentration of H plus ions. Now just please remember that the H plus ions is the same thing as the H3O plus ions. Okay, both of these forms are acceptable. All right, so you've got to look at the question. What information does it give you? It gives you the concentration of HCl. The concentration of HCl is equal to 0.04 moles per liter. This just so happens to be the same as the concentration of H plus. Okay, we know this because this is a strong acid. Alright, so the concentration of the HCl will fully ionize, and therefore you're going to have the same concentration of H plus ions. And then we can solve for this. pH will be equal to the negative log of 0.04, which will happen to be, says Mr. Calculator, 1.40. What's the unit for pH? Doesn't have a unit. Okay, so please make sure that you remember that this pH doesn't have a unit, it just has a number. Alright, so that's the first question. Please remember that if you are given a volume, you do not necessarily need to use it. Concentration is what you need to remember to use for pH calculations. Let's go look at the next one. Determine the pH of a solution where 13.85 grams of 96.4% pure nitric acid is placed in a 500 ml volumetric flask and made up to the mark. Okay, so 13.85 grams of 96.4% pure HNO3 is placed in a 500 ml volumetric flask and made up to the mark. Okay, so a couple of things. We need to work out the pH of this, so we need to get the concentration of this, which means that we're going to need to work out the number of moles and the volume. Okay, well, we've got the volume there. So, where should we start? We can work out the mass of the HNO3, because we've been told that it's only 96.4% pure. It's got 13.85 grams of it, so it'll be 13.85 times 0.964, which will be 0.964, 13.35 grams. Okay, please remember to save these values in your calculator. Otherwise, you will end up not having the exact value when you get to the end. All right. So now we can work out the number of moles of HNO3. Okay, which will be equal to 13.35 over the molar mass of HNO3, which happens to be 63.018. Okay. Now, if I was just to retype in 13.35 into the calculator, then I'd have the incorrect number. All right, I'd be off by a little bit. So I'm going to use A divided by the 63.018. So A divided by the answer is equal to 0.212 mole. And I'm going to save that to B. All right. Now I need to work out the volume. Okay, the volume of the HNO3 was made up in a 500 ml volumetric flask. So the volume is 500 mils, which is also equal to 0.5 liters. Remember that volume needs to be in liters. Then I can work out the concentration of HNO3, which will be equal to N on V, which will be equal to 0.212, which is B, over 0.5, which happens to be 0.424 moles per liter. Okay, now one really important thing is that you've got the concentration of HNO3, you haven't actually got the concentration of H+. Well, technically you do, because they are the same, but you need to show it. If you do not show it, you may lose out on that mark. Alright, so please make sure that you show it, and this will be important when you get to things that aren't a 1-to-1 ratio. Alright, so that's the number of moles of the H+, the concentration of the H+ ions. Now we can solve for the pH. pH is equal to negative log 0.424. Negative log answer 0.373. Okay, remember there's no unit in the pH. Can the pH be less than 1? Absolutely. It can be less than 1 if the concentration of H+ ions is greater than 0.1. Okay, just remember that your pH values can be any value. It can be a negative value, it can be above 14, things like that. So please don't think that it's just between 1 and 14. Okay, so that's the second question. All right, let's go to the next question. The next question. Determine the concentration of hydrogen ions in a solution with a pH of 3.5. So the pH is equal to 3.5, and we're looking for the concentration of hydrogen ions. Okay, so do you remember the way that we can work out the concentration of H+ ions from the pH? The H+ ions is equal to 10 to the power of negative pH. Alright, so that's 10 to the power of 3.5. No, it's negative 3.5. Alright, so 10 to the power of negative 3.5. Please make sure that you use your negative button on your calculator, not your minus button, otherwise you will make the calculator very confused. And it's 3.16 times 10 to the negative 4. Right, what unit is this? Moles per liter. Right, so please remember this equation. You do really need to know how to apply this equation in the waste exams and other things. Okay, so concentration of H+ is equal to 10 to the power of negative pH. Alright, let's go to the next question. Determine the volume of hydrogen chloride gas, HCl gas, which would be needed to create 200 ml of solution of hydrochloric acid with a pH of 2.8. Okay, that's the full question. So, the mass of HCl gas required to make 200 ml of hydrochloric acid with a pH of 2.8. So this involves a couple of steps. Alright, in fact, was it the mass? No, it wasn't, was it? It was the volume of hydrogen chloride gas at STP. The volume at STP. Right, the volume of HCl at STP. So, we have to think about what is actually our known. Okay, our known here is the pH of 2.8. We're going to work backwards from there to get to the volume of HCl needed. Alright, so the pH is equal to 2.8. The concentration of H plus is therefore equal to 10 to the power of negative 2.8. 10 to the power of negative 2.8 is 0.00158. I'm going to store that in my calculator. A. Right, so that's the concentration. Now I need to work out the number of moles of H plus I would need, right, because I'm going to make 200 ml of this solution. So the number of moles is equal to CV, concentration, which is over here, times the volume, which is 0.2, because remember it has to be in liters, and I get 0.000317 moles. Okay, store that as B. Again, I've got the number of moles of H plus, but I do not have the number of moles of HCl. I know that it'll be the same, but you need to tell me that you also know that concept. Right? So the number of moles of HCl will be equal to the number of moles of H plus. Okay, so now I need to work out the volume of HCl. Okay, I guess I should really do this. The number of moles of HCl gas will be equal to the number of moles of HCl AQ, which will be equal to 0.00317 again. But now then I have to work out the volume of HCl gas, which will be equal to N times 22.71. Where's this equation come from? It's the STP gas equation, where N is equal to V over 22.71, so therefore V is equal to N times 22.71 at STP, right? So we take that value, times it by 22.71, and we get 0.0071720, and that's in liters, which converts to 7.20 mils. All right. So that's what you would need to do. You start off with the pH, you work your way to work out the concentration, work out the number of moles, make sure that you're showing that you understand the link between the number of moles of H plus and the number of moles of the actual substance making the H plus, and then again the substances between the aqueous and the gas, and then the volume to work out the volume of gas needed. Alright? So, let's go on to the next question. The next question is, determine the pH of a 400 ml solution of 0.95 moles per liter sodium hydroxide. So this is our first example of working out the pH of a base. To work out the pH of a base, you still need to do the pH is equal to negative log H plus. However, you don't have H plus so easily, so we need to use a number equation, where Kw is equal to H plus times OH minus, or H3O plus times OH minus. Alright, which is equal to 1 times 10 to the negative 14. So, this is your Kw equation. So we're going to use this equation to get this, so therefore we need to get the number of moles of OH, and then with the number of moles of the concentration of OH, we can go work out the concentration of H plus and therefore work out the pH. So, what other information was given to us in the question? 400 ml solution of 0.95 mole per liter sodium hydroxide. Right, so we can work out, no, again, it's trying to trick you. You can work out the number of moles of NaOH, but do you need to? You're not needed. You do not need to work out the number of moles of NaOH. You only need to work out the concentration of NaOH, which just so happens to be given to you as 0.095 moles per liter. Right. Again, you need to show that you recognize that you understand that the relationship between the NaOH and the OH minus is a 1-to-1 ratio. And then once you have that, we can apply Kw. Okay, so the Kw equation, we want to work out the concentration of H plus using this equation and this value here. We know it's going to be 1 times 10 to the negative 14 over the concentration of OH minus. This is you being able to algebra, okay, going from this line to this line here. Okay, so we know it's then going to be 1 times 10 to the negative 14 over 0.95, which happens to be 1e to the negative 14 divided by 0.95 is equal to 1.05 times 10 to the negative 14. All right, this is now the concentration of H plus. Okay, so now we can work out the pH, because it's equal to the negative log of this H plus, neg log 1.05 times 10 to the negative 14, which is equal to negative log answer 13.98. Right, and make sure that you're saving your values, otherwise you're not going to get the exact value that you need. Right, so just remember, even though you have the ability to get the number of moles of NaOH, you don't necessarily need it because you need the concentration of NaOH. Right, and don't forget to show this step here. I know it's a 1-to-1 ratio, but it won't always be. So please make sure you always show that step. Right, what's next? This one here, which will have a lower pH, a 200 ml solution of barium hydroxide, 200 ml solution of barium hydroxide with a concentration of 0.05 mole per liter, or a 100 ml solution of sodium hydroxide with a concentration of 0.08 moles per liter. Alright, so here we have our two substances. Again, we are being given information that we do not need. We do not need the 100 mils here. We do not need this 200 mils here. It's just trying to trick you. So let's work out what we need to do. We need to work out the pH of both of these things, don't we? Therefore, we need to have the H plus ions of both and to get the H plus ions of both, we need to work out the number of moles of, or the concentration of OH minus ions of both. Now we're given the concentration of these two things, so let's have a look. So the concentration of Ba bracket OH bracket 2 is equal to 0.05 moles per liter. Now you'll notice that this is barium hydroxide. This is Ba bracket OH bracket 2. Right? If you didn't remember that Ba is in group 2 and the hydroxide of it is, the hydroxide is a 1 minus ion, so it makes Ba bracket OH2. Then you really need to be remembering your ions. But this then leads us to the reason why we actually bother putting in this step. Because the concentration of OH minus ions will be equal to the concentration of barium hydroxide times 2, which will happen to be 0.1 mole per liter. Okay, so this is why this step is important. The relationship between the hydroxide ions or the hydrogen ions with the concentration of whatever chemical you're working with. Alright, so then I can get the Kw equation going. 1 times 10 to the negative 14 is equal to concentration of H plus and OH minus multiplied together. So therefore the H plus ions is equal to 1 times 10 to the negative 14 over 0.1, which happens to be something. 1 times 10 to the negative 13. And then we can work out the concentration of the NaOH, which happens to be 0.08 moles per liter. Again, the concentration of the OH minus ions is equal to the concentration of the NaOH times 1 this time, which means that it's 0.08 mole per liter. We're going to use this Kw equation again to solve for the concentration of H plus, 1 times 10 to the negative 14 over 0.08, which will not be so easy to solve. 1 e to the negative 14 divided by 0.08, 1.25 times 10 to the negative 13. Alright, so what's that equal then? That equals the... Now we can work out the pH of both of these. Alright, so pH is equal to, for this one here, is equal to, let's save this one as B. Right, this one here is 1 e to the negative 13, negative log that, negative log bracket 1 e to the negative 13 is equal to 13. Right, and this one here, the concentration of OH minus ions there is 1.25 times 10 to the 13. Right. Okay, so that's 1 e to the negative 14 divided by 0.08, 0.25 that, so I'm going to do negative log answer, which is equal to, pH is equal to 12.9 here. Alright. Again, you just need to make sure that you probably should have put in the negative log 1.25 times 10 to the negative 13, and this one should be pH is equal to negative log 1 times 10 to the negative 13. Right, so this is pH 13, this is pH 12. The question actually asked what? Which one has the lower pH? Which one has the lower pH? It's this one. Right, technically this is more acidic because that's what you wanted to know, because it's of the lower pH, right, and so therefore it's the sodium hydroxide. Alright, let's have a look at the next question. Determine the final pH when 100 ml of 0.6 mole per liter, 0.06 mole per liter, 100 ml of 0.06 mole per liter sodium hydroxide is mixed with 120 ml of 0.04 mole per liter hydrochloric acid. Okay, so a couple of things you need to remember. You need to know the general equation for this. The NaOH and the HCl is going to make the NaCl plus H2O. Alright, and so this is effectively a limiting reagent question plus a excess question. Alright, so let's go start working through. How do we do a limiting reagent question? Or how we do a limiting reagent? We need to work out the number of moles of each of these. So the number of moles of NaOH is equal to concentration times volume, which is 0.06 times 0.1, which happens to be 0.06 times 0.1, 0.006 mole. I'm going to store that as A. The number of moles of HCl is equal to CV, which will be equal to 0.04 times 0.12, which happens to be 0.0048 mole, and I'm going to save that as B. Right. Remember, you've got to do the full limiting reagent working here, so the number of moles of NaOH needed will be equal to the number of moles of HCl times 1 on 1, because you've got a 1 on 1, 1-to-1 ratio over here on the equation, and this will be 0.0048 mole. Then I can say, I compare my needed, which is this much here, versus how much I have, which one is greater. The number of moles of NaOH have is greater than the number of moles of NaOH needed, and therefore the HCl is the limiting reagent. Alright, so I have more than I need, therefore this is not the limiting reagent, the other one is the limiting reagent. Okay, so now that I've worked that out, I can work out how much NaOH is left over to work out the pH of the substance. Alright, so now I have to work out the number of moles of NaOH excess is equal to the number of moles of NaOH have initial, subtract the number of moles of NaOH used by the HCl. Alright, this value here, the number of moles of NaOH used, will be equal to the number of moles of HCl times 1 on 1, which happens to be what we've already solved over here, 0.0048 mole. So therefore we can say that this is 0.006 subtract 0.0048, which happens to be 0.0012 mole. Okay, again, you cannot use number of moles to solve for anything. You have to work with concentration. So now we have to work out the concentration of this. Okay, so we've got the number of moles of NaOH which is in excess. We need to work out the concentration of NaOH in excess, which happens to be N on V, which will be 0.0012 over, now what's the total volume here? So the volume of the mixture will be equal to, and you just have to think back here, we had 100 mils and 120 mils, so that makes 220 mils all up. Okay, and therefore we're going to have 0.220, and so we're going to be able to solve that. 0.006 subtract answer and divide that by 0.22, which is equal to 0.00545 mole per liter. What's the next step? I need to show that I understand the relationship between the OH minus and the substance. And even though I know it's the same, I better write it out. Then I'm going to work out the concentration of the H plus ions. How am I going to do that? Using the Kw equation. Concentration of OH minus. So therefore it's 1 times 10 to the negative 14 over 0.00545, which happens to be something like 1e to the negative 14 divided by 0.00545. Oh no, if I type that in, I'm going to get the wrong answer because I have not done that right, because I can't just type it in, so I'm going to use the old saved answer, which is 1.83 times 10 to the negative 12, right, mole per liter. Now I can finally work out the pH of this, negative log this, 1.83 times 10 to the negative 12, which happens to be neg log answer 11.74. What's the unit for pH? There is no unit. Alright, So that's how you would work out that. You've got to remember, this is a limiting reagent question. You've got to work out all of the steps of limiting reagent. Steps 1, where you've got to work out the number of moles of each. You've got to remember also write out the equation. Step 2, how much of one you need. Compare how much you have versus how much you need, and then work out the limiting reagent. Which one's the limiting reagent? Work out the excess by how much you have, subtract how much is used. And you may have to calculate for how much is used, or you may have done it before. Work out how much is in excess. Remember that we are dealing with concentration of NaOH excess. Remember to combine the volumes of the mixture. Work out the concentration and show the concentration of OH compared to whatever you are solving. Use kW, work out the pH. Okay, let's go through the last question. And the last question is, determine the final pH when 50 mils of 3 molar sodium hydroxide, 50 mil, 3 mol per liter sodium hydroxide is mixed with 100 mil of 0.7 mol per liter sulfuric acid. And then you take these two and then you make it up to 500 mils in a volumetric flask. Alright, so that's the start, that's what we're going to do. So first things first, we should probably write out an equation. NaOH plus H2SO4 goes to Na2SO4 plus H2O, double that, double this. Right, if you don't remember all of your acid-base equations, you really should brush up on them. Right, now we can go on and do our limiting reagent information. Number of moles of NaOH will be equal to CV, concentration 3 times 0.05. 3 times 0.05 is 0.15 mole. Save that as A. The number of moles of H2SO4 is equal to CV, which is equal to 0.7 times 0.1. 0.7 times 0.1, store that as B, which is 0.07 mole. That's B. Alright, now we can work out the number of moles of NaOH needed, which will be equal to the number of moles of H2SO4 times 2 on 1. 0.07 times 2, which is equal to 0.14 mole. The number of moles of the NaOH that I have compared to the number of moles of NaOH that I needed. Which one is greater, 0.15 or 0.14? It's the 0.15. So I have more than I need. Therefore, again, the H2SO4, the acid, is the limiting reagent. Now let's work out how much of this NaOH is left over and affecting the pH. So the number of moles of NaOH excess will be equal to what? The number of moles of NaOH that I initially had. Subtract the number of moles of NaOH that were used by the sulfuric acid. This is how much was used. This is how much I started with. So 0.15 subtract 0.14, 0.01 moles. Okay. Again, you can't just use the number of moles of things. You have to go into concentration. So remember that they made it and put it into a 500 ml volumetric flask and made it up to the mark. So the concentration of this, the concentration of the NaOH excess will be equal to the N on V, which happens to be 0.01, over, what's the total volume? The volume of all of the stuff is equal to the 500 mils, because it's put into the 500 ml volumetric flask and added water to it, so it's not going to be the combined volume of the two. Okay, so that's that. And now that is, so 0.01 subtract or divide by 0.5 is 0.02 mole per liter. What do I do now? I still need to work out the pH, so I need to go and get the concentration of H plus ions, but that sounds like I'm missing a step. What step am I missing? I've got to get the concentration of OH minus from the concentration of the NaOH, which will be equal to 0.02. I know that's the same, but that doesn't matter. You still got to show it. All right, and then I can work out the concentration of H plus is equal to 1 times 10 to the negative 14 over this value, which happens to be 1 e to the negative 14, 1 e to the negative 14 divided by the answer, which was equal to 5 times 10 to the negative 13 moles per liter. And then I can work out the pH of this negative log answer, which is equal to 12.3. Okay, so please remember to read the question and get out all the information that you need. You're not going to add these two volumes together. You're going to go use the total volume. Okay, please remember to do the equation. Please remember to take into account the stoichiometric ratios. Please remember to do this, because that's very important. Please remember to do this, very important. And please remember to stay in concentration, not in number of moles. Okay, that's pH calculations. Hope you had fun.